My name's Morna and I'm a science communicator. Now that means I'm a really big fan of science. I spend my working days chatting to people and enthusing them about science and occasionally making things go bang. Now you might not think that science is particularly important or interesting, but it's my job as a science communicator to make those scientific concepts much more fun and exciting for you. At university, I studied zoology, and I've always been interested in how the design of certain animals have been used to benefit humans. Now I'm going to bet that if you ask any child what they wish that they could do, and the vast majority would say fly. Unfortunately, humans can't fly. So what we do is we use machines such as planes. But even some of those planes have been designed using inspiration from the animal kingdom, in particular, birds. In simple terms, flight in birds can be divided into two categories: flapping flight and gliding flight. Flapping flight is much more energy consuming and is only really used in smaller birds, such as the ones you'd see in your garden. Obviously they've got a smaller body size and a smaller wing size. Gliding flight, kind of like this, is only really used in your larger species such as birds of prey, and they have evolved to use this kind of flight so that their wing size generates more lift without producing as much drag. So in order for my trusty airplane here to achieve flight, it has to employ the four principles of thrust, weight, lift and drag. Thrust is the force that pushes that airplane forwards through the air. Its opposing force is drag, which is trying to pull it in the opposite direction. So in order for flight to be achieved, the force of thrust has to be equal to or greater than the drag. Now, every single object on Earth has a weight, even this tiny little ping pong ball. If I bring in my ever reliable hairdryer and I place that ping pong ball on top of it, that ping pong ball will stay there forevermore until I switch it on, provide it with a moving source of air, thus giving it lift. Sorry. Now I know that not everybody has access to scientific equipment, but that's one of the best things about science, because you can conduct experiments in your own home. One of my personal favourites is cornflower goo. Now all it is corn flour and water, and I've added some food colouring to mine to make it look pretty. Cornflower goo is an example of a non-Newtonian fluid. Basically what that means is it can act as both a liquid and a solid. If I stir it slowly with my finger here, it looks and acts like a liquid. But as soon as you apply a force to it, it acts like a solid. And what's happening here is the cornflower particles themselves aren't actually dissolved in the water, they're just kind of suspended and they slip and they slide over one another until you apply a force to it, like my fist. And once that happens, those particles lock together. When I was at school, I was a biology girl, and that was the reason why I studied zoology when I went to university. But I also had a little bit of chemistry thrown in. And I absolutely hated physics. But physics is what allows me to lie on this bed of nails and not get injured. So what further proof could you need that science is absolutely amazing?